Okay, Twitch stream started. Sure. Visual Studio Code. Let's start this game. Let's make a game from scratch. Open recent. GLFW. Okay, should be live. There. This is my own programming language in plain English. This is what we will code in. And all of this under the hood is C++, OpenGL, and GLFW. I've been following this guide. I've been following this. I've went through the getting started session. This is the best OpenGL resource, and what they show after. I haven't went through all of the getting started guides. I ended to coordinate systems. I haven't gone through camera, but I think I have good enough knowledge to start playing around. And today we will be making a game. We'll be making a game, this breakout game, more like this, where they have a guide on how to do this game through all of this, where they go through levels, etc. I haven't read it. I just picked to see what's up, and their examples are quite a bit complicated, and I'm not on that level yet. So the best way to learn is to play around yourself. So that is what we're going to do, even though we lack a lot of knowledge. Even though that, we will try our best. And we need Visual Studio for GLFW. And okay. Let me open chat. Why is chat not opening? Okay. Now, this is the code that gets generated under the hood. All of this code is actually this. It's the same thing. Let me increase the font size. I hope this can be seen better. And so when I run it, this is what I have right now. Here I've created two rectangles. Each rectangle is with two triangles created. This one rotates slowly, and this one scales up, becomes bigger and smaller. These two rectangles have two textures on them. The wooden texture and this smiley face. Not only that, but if I press the down arrow, the opacity of the second texture lowers. And if I press the up arrow, the opacity increases. This is what I've made so far. following the tutorial. And this is all I know. This is all I know. I have in plain English some commands. Let's see some example of a command. Here is to activate the shader program, and we give it a shader program. It just uses GL use program and then the shader program that we've given here. Let's start some music. It's a bit loud. Let me lower it a bit. Okay, now this is what we have, and we have about 4 hours. There's a lot of things I want to mention off stream, but we don't have the time for it. We're aiming for 4 hours. I want to mention about this application, about this that I worked on the whole day yesterday on the lower part of the screen for showing chat messages from both streams, but we have to focus on making the game. Okay, at most 4 hours, let's see how far we can go. Let's see how far we can go. This is all we have right now. We can just start from scratch file, not with this. We can start from a scratch file and remove all of this. Why is this opening? This is every time opening on the other window. Man. This may be a pain. Okay. But how to start? Let's open another file. We'll call it just test, and let's move this here, and let's start it. Okay, so what we will need to include OpenGL, GLFW, read and write to console, our shader header file. I've moved all the code for the shader separately. We'll need an image loader for the loading the textures, and GLM. What was that? I think that's for math. Yeah, that's for the math. Yeah, let's copy that. Next, variable for the opacity. This is for when we lowered or increased the opacity with up and down arrow. We don't need it. Declare function frame buffer size callback which updates size of rendering. Yeah, we will need this. This is just for when the window updates its size and what to do about it. Declare function. Here it is. It's just a function which is called with width and height, and we set GL viewport to that new width and height. Next function, process input. Here we process the input. We'll copy this and change it a bit. So this function, processing input, it takes up an argument of the window, and the definition of the function is that when we press escape key, close the program. If J or K key, like when I set up and down arrow, for me it's J and K key because of I use touch typing. So here we decrease the opacity or increase the opacity. Let's delete this and just have the escape key for closing the program. Declare float array vertices. These are our vertices that we declare. Declare float array. Vertices with color values and texture coordinates. Yeah, these are the these are our vertices. What vertices will we be using? So currently, let me just copy them to be easier to see. These are our vertices for that triangle. So these are the coordinates of, top right of the rectangle. This is the top right coordinate. So the origin is at 0, 0. 0x, 0y, and 0z coordinate. That's the origin. So when we say for the x 0.5, this is, I think, to the right, and 0.5 for y-axis is to upwards. So top right. This is the top right coordinate, vertice, the top right vertex, and then the color. Yeah, we will need color, but when we have a texture, the color is ignored. So this red, green, and blue. So this is red color, green color. This is the blue color. And then here once again red and green. Then for the texture coordinates, when we give it a texture, we need to say where in the texture the vertex should be. But the texture vertex, the origin. Let me just show you. It will be quite faster. Getting started, OpenGL. Like here they say that they would be thankful if I'm not using an ad blocker so that ads can show and they can earn something, but I stopped my any ad blockers that I could see, but still these ads still don't show up, and that's a bit confusing. Maybe the browser itself has some removal of ads. I'm trying to see for the coordinates. It will be a lot faster to explain. Hello triangle. This is about the shaders. We are not calling shaders yet. Oh, okay, here it is. Here, as I said to you, the origin is at the center of the screen. And when we say on the x 0.5, it's to the right. And the y-axis, if it's negative 0.5, it's down. But we were talking about here the texture coordinates. The texture coordinates are a bit different. Let me go to textures. They're a bit different. Here they are. They start from change pole standing. Have to stand up. Okay. Come on, this microphone is. Oh, I hope this didn't be too loud when I'm moving the microphone. Okay, this should be fine. Test. Okay, for texture coordinates, it's to the bottom. It starts from the bottom left. So here, oh come on, man. Let me move it back. So when where's the code? Here, when we say the texture coordinate of 1 and 1, this is top right as well. This is a bit annoying, having different origins, but we don't make up the rules. So when we say, what we're saying here is that the top right vertice of our rectangle should be mapped to the texture in the top right of the texture we're giving it. Here, this should be right, bottom right. This should be top, bottom left. This should be upper left. Once you know where the origin is, you can figure out how to set this up. We will use this to create our game. How? Let's open the in practice 2D game breakout. How we will use it? We will use it to create. We will start by making these rectangles. We will just use colors. We will not use a texture for the. Well, let me open some place where it's easier to see. Levels. This. We will start with these ones. With these orange, green, and blue ones. We'll make them first. And then the paddle. And then the ball. I'm not quite sure how we will make the ball because we're working with triangles. We will see if there's a primitive of a circle. So let's delete these vertices. And let me check Streamlabs. Okay. So we will declare some vertices just for testing purposes. Okay, I need to start my compiler. Rules EP. This has its own compiler. I've made a compiler from English to whatever language you've picked. let me check and see how this, when I set translate code and I pressed enter, it translated all of this into this. Here we have all our includes from this, and we have our function. Here is the frame buffer function, and we have our process of input. When the escape key is pressed, we will close the window. And that's it. We don't have to remember all of these complex things. It's not as scary when we're programming in OpenGL. When we're programming in plain English, it's not as scary. And you're only focusing on the the knowledge, not having to learn the syntax. And it's very easy to play around, and we learn the most when we play around. And so I'm trying to prove here the value of coding in English Plus by making game from scratch. So let's make the vertices. Let me increase this, and we will copy this, and we'll make new ones, probably. No. Let's use the same ones. Later on we will make changes. Let's use the same ones. So declare float array named vertices with value I haven't added auto completion inside the parameter. Versus with colors and coordinates. So I have to copy this and go back here and paste. What's missing? Versus with color values and textures. Yeah, it worked now. It worked. It should be with lowercase. Next. What else? Oh, I have to start the server. No, it started. Okay. I was thinking I didn't start the server for my chat. We have our vertices next. I have to increase the speed because I want to finish the game in 4 hours. Next, what else do we need? Declare float array. Okay, starting point for the program where program execution is. So we instantiate glfw. These are boilerplate things that we use every time. We create the window, initialize glad so we can call OpenGL functions. Let's check up the glad thing. Initialize glad. GL glad load GL loader. These are just boilerplate things. Create window, initialize glad, tell OpenGL the size of the rendering window, and on every window resize call frame buffer size callback. Okay, so here this tail OpenGL, the size of the rendering window, is the same as what we did here in declare function. What we did when the window resizes. And let's skip all of these. Change pose. You have to change pose, chat. Test. So, what our focus now is to make our focus is to make a very basic version right now. Our focus is a very basic version. So our focus is a basic version. So we have on resize that we should call the function to update the actually where we are rendering the OpenGL stuff. Next, we will skip shader program, declare variables, skip this, skip the generating of the texture, skip this, create element buffer, the OpenGL, how, no, skip this, set uniforms, okay. We go straight to start render loop. Drawing images, I should have called this a bit better. And what do we do in the render loop? We, this is for processing, yeah. We have to process the inputs. So this is a while true loop. This is while true loop that where we will render everything. Yeah, we can set the background color. And what else? Activate texture, no, create identity matrix. Create identity matrix. Copy this. And then to properly delete all of GLFW's resources. Now, when we, okay, it's already translated. It translates on every save. So now let's start this. And here it updated with all the code. It's not that much code. And when we start it, we get this window. We get this window, and that was it. Now, let me give a bit context on this. So, this is starting point for our program. So it's just, I think, the main function. It's just the main function. We create tail OpenGL, the size of the rendering window. Okay, telling, yeah, we'll go over OpenGL size of rendering window. We'll show it in a bit. On every window resize, and we'll show this afterwards. Rendering loop. Process input. Okay, this function we call the process input function, which is this function here. This is just so when we press the escape key, the application should close. Here, when we start it, If I press the escape key, it closes. Swap the currently shown buffer with the one we finished working on. This, okay, OpenGL has two buffers, the front and back, I think they're called. So one of the buffers is what's currently on the screen. The other buffer is what we're drawing on. When we're done drawing on the background, when we're done drawing on the second buffer, we swap them and now we show the finished thing. This is because if we are working on one buffer, like the main window, if we're drawing directly, if we draw directly here on the screen, it will be kinda, there will be issues like some flickering, etc. To make it more smoother, OpenGL is drawing where you cannot see. It's drawing in the background. It's like a painter drawing, it's painting without you seeing and just showing you the end product. You're not seeing OpenGL draw. You don't have to, if you're struggling to understand, it's very normal because I did my homework and I just spent a lot of time learning the basics. So it's normal if you don't get it in a few minutes. Check if any keyboard or mouse key event are triggered. I think this is just to let's experiment to see what will happen if we don't have this. We save and let's start and let's see if keyboard keys are registered when we remove that. Okay, the window is not responsive even. It opened on my other monitor and it's not responsive. It's not responsive at all, so we do need it. So for any mouse events, any keyboard events, we check them here. If we don't check them, the window is not responsive. So turns out this is important. Then properly delete all of GLFL resources. This is just properly delete. This is just GLF double terminate, but we can at this point we can delete all the resources that we don't need because this is the end of the program. But I think this just for now doesn't do much. Yeah. So now let's render our vertices. So here we declared our vertices. We will render them without the texture, just color. We will use just color. So we have, this is just an array of floats, our vertices. So we have to give a bit of context for OpenGL on what to do with them. How are we with the time? Okay, it's still less than an hour. Okay, what do we need to do? We have our window working. Now we just want to show our rectangle on the screen. Okay, we create our shader program. We create our shader program with our vertex shader and fragment shader. We may look at them at some point, but we need a shader program for if we want to, because we want to color the rectangle with colors, and we want to use textures as well, and for and for moving the objects, resizing them, And rotate, no, we don't need to rotate them. So for moving and resizes, we need the shaders. And also for OpenGL, we have to tell OpenGL, the vertex shader and fragment shader, what they are. Like we have to give them the code for the shaders because there are no default vertex and fragment shaders. We'll go over shaders probably at some point. Next, we declare variables for image loading. No, we don't need image loading right now. Okay, we have audio. We have the screen, okay. This is just to generate the texture. This is again for a texture. Okay. Now we will create maybe the most complicated part. Create vertex array object with name. Yeah, let's just call it VAO. This is a VAO. Let's just I'll just write the code for rendering the rectangle, and we'll go over what this VAO, VBO, etc. We need to bind it. We need to create a vertex buffer object. We need to bind the vertex buffer object. We need to copy the vertex data to the VBO. Okay, we need to tell how to interpret all of the values. And we need an element buffer object. Unbind the vertex array object. Yeah. Okay. Let's paste them. We'll go over this. Let's just render the rectangle. Next, in the render loop, swap currently buffer. Okay, here. What else? Activate texture. Texture. Activate shader. Activate texture. Bind texture. Activate shader program. We need to bind the VO. We need to get uniform, transform, set uniform, draw rectangles. We need to draw the rectangles and unbind the VO. Okay, let's see what we have right now. Okay, right now the rectangle is it doesn't have a color. Usually this is because with issues with the shader. I think we need to activate it. We have to activate it. Where was it? Where was activate shader? Activate shader program. Vertex array here. And now let's start it. Nothing. Am I using the... Is it trying to use a texture, is what I'm wondering. Is it trying to use a texture, is what I'm wondering. So we managed to draw the rectangle. Now the issue is giving it a color. It should get a color. Let me also open the fragment shader. I quickly want to render the rectangle with just colors, not textures, and give you a bit of context on what's happening. Oh, but where's the fragment shader? I think in resources, fragment shader. So the color is a mix of both. Okay. I understand. For the OpenGL code, I'm not using English plus, like coding in English. I'm using it just for everything else. The audio is not clipping, right? Yeah, it's not clipping. It's even... Yes, not clipping. I just want you to have a good experience watching this. So we will delete this. And we will say that the color is equal to... So as in, we get the coordinates. Why are we not getting any color? Why is there not an out? Oh, I'm not... Okay, I understand. A color. This is a vec3, yes, a vec3. And we will output vec3 colors. Like once we render the rectangle, I'll give a bit more context. And then the colors, we say that they are a color. This here, we are getting it from the array we created, the vertex array. The position is the first three float values, the color is the next three float values, and the texture coordinates are the final two float values. So we need to copy these colors and go here, paste them in, and here it should be a vec4. Like, did we do it like that? Yeah, vec4 of our colors, and the alpha should be 0.1. And we do this. Now let's execute it. Still, it's struggling to do it. Let's go back and delete this, and let's try again. Now it's without it. So we are getting the colors. We are setting an out variable of colors, that is the input of the three colors at location 1. And then in the fragment shader, where we have to say what the color of the vertices should be, we set it to colors with alpha 1. Okay, shaders should be fine. Here we declare a float with the vertices, and we create the shader program, create the VO. Have to stand up. We're missing something small. Something really small. We're missing something really small. Test. Man, we're almost at an hour and we're still trying to render some rectangles. Next. Okay, we create the shader program. We create the VO, we bind it. We create the VBO, we bind it. We bind it. We copy the vertex data to the VBO and we put in the 0 to 1 with size 3, starting from 0 with a stride of 8. Yes, the stride is always 8. And we're starting from 0. For the colors, it's of size 3. Stride 8 and size 3. No, the offset is 3. And for the texture coordinates, with size 2, stride is 8, offset is 6. Okay, this should be perfect. We create an element buffer object, tell OpenGL how to form a rectangle, unbind vertex area. Okay. Next, we bind the VO. Where is the activate? Activate shader program. True shader class. It's not showing anything. What? Let me think. This is really weird. At least the vertices should be showing. Okay, I have an idea. Let's just go into the fragment shader, and for the should this be like X, Y, and Z? I'll try the idea. 1 second. Okay, it's the same. Okay, let's force some colors here. No matter how much we F up, this at least should give something. So red, green, and blue. So the rectangle should be red here. The rectangle should be red. Still nothing. What? Oh, okay. Let's try. Let's try removing this, because this is the only time it showed something. Still black. Let's go over what we're missing. Draw triangles from EBO using 6 number and by the swap currently check. Okay, so we're calling press set background color. Okay, activate texture, bind texture, activate texture, bind texture, activate shader program. fixate float uniform to opacity. We're ignoring opacity right now. Bind vertex array object. Yeah, we're binding it. Oh, is it because of the yeah. Yeah, let's because in the vertex yeah. That's right. The shaders are working because here for the position we're using the matrix for transformations. So let's ignore it. And let's move here. Yeah. It makes sense. And then we started. What? It's working. Oh my god, it's working. Dude, it's working. I fixed it. This is what I'm talking about. The power of coding in plain English. Because if I struggled with this problem, if I had to solve the problem looking at this code, like this mess, try to solve the problem just looking at this. We managed to solve the problem just coding in plain English. Like, how amazing is this, man? So, we'll go over what actually happened. Should I open this main? We created this just a vertice array. We created the vertice array with our positions. It's just a simple array of float values. And we made it up like this. Like, we decided the vertices should be here. We decided that the colors should be here. We decided that the texture should be here. So we have to tell first our main goal is to tell OpenGL, like, our first goal is to give all of this information to I think the GPU. We have to first give the information to OpenGL, and the second goal is to tell it how to interpret it. These are the two main goals, and that's what we did. First, we created the shader program. We'll go over the shader program afterwards, but before that, we create a vertex array object. Now, should I go into vertex array objects? Let's go into VBOs. Vertex buffer object. So we create a vertex buffer object. Inside a vertex buffer object is where we store our data. And here it is. We copy vertex data to the VBO. That was our first goal. We gave the data to OpenGL. Now the second goal, it's right here. We tell it how to interpret it. We tell it to put in vertex attribute 0. What's that? It's this in the vertex shader. This is vertex attribute 0. So in our apos variable, in our position variable. Inside it, we are putting data of size 3. Of size 3 because our positions are 3 float values. So imagine it starts from here and it says, imagine it starting from here and we're telling OpenGL, from here, get 3 float values, and you will put them, put them inside this inside this variable in the vertex shader. Starting from 0. So literally starting from here, the 0th position. We have to see chat. We have to sit. This should be more like this. Test. So, this working. Maybe we'll. I really want us to have some kind of a game after 4 hours, but explaining everything slows down things a bit, but I want you to have at least some context. And the stride is 8 float values. So what does the stride mean? So what we told it is that it should start from the first position, 0. It should start from the very start, the 0th position. It should take 3 float values, and it should send them to this variable. And the stride is 8, so once it's done, it will skip 8 values. So from the 0th position, it goes over 8 values, and it's right here, and does the same thing again. These three, it takes 3 float values and inputs them into the vertex shader. Then and then the next 3 float values, and then the next 3 float values. This is just for the position, and then the others are the same. Like this is for vertex attribute 1, which is the colors, and it's a vector of size 3. And once again, we are saying the size is 3, and the the offset is 3. So instead of starting from 0, it has an offset of 3. So it starts from here, and it's 3 float values. And the stride is 8. So once again, it skips 8 floats. So 1, 2, 3, 4, 5, 6, 7, 8, and here it reaches the 9th here. Again, it's the color. And it gives all of that to the color variable. And literally the same thing is for the texture coordinates. The stride is the same, the offset is this time 6, and it's for the vertex attribute 2. That's it. That's our vertex. That's the job of the vertex buffer object, and it's doing most of our work. So what is this vertex array object, and what is this element buffer object? So the vertex array object is so that it remembers. Okay, let's go to the element buffer object. What is the element buffer object? Well, we gave OpenGL all of these vertices, like top right, bottom left, and top left. But there are no rectangles in OpenGL, I think. They're primitive objects that render on the screen. One of them is a triangle. So what we gave it is the vertices of a rectangle. We gave the vertices of a rectangle, but we want but it has to draw it with triangles. And how we have to tell OpenGL how to use these vertices to draw a rectangle. And that's the EBO. The EBO is this thing, these indices. We are telling it how to render the first triangle. So get the vertices 0, 1, and 3. And this forms one triangle. 0, 1, and 3. So it's 0, 1, and the last one. So top right, bottom right, and top left. And that is our first triangle. So if we start it, and we so it's top right, bottom right, and top left. This is our first triangle. And look at how we just and the other triangle is bottom right, bottom left, and top left. So look at how we are using the same vertices over and over again. That's the element buffer object. We can render without an element buffer object. It's possible. But we would have to repeat vertices in these vertices array. We would have to repeat vertices. But with the EBO, we can just say with this, and this vertice, form a triangle. With this, and this, form another triangle. That's the job of the EBO. And finally, the vertex array object, its job is just to manage all of this. What I mean with this is that this is just our triangle. But let's say we have a circle and we want to render the circle now. So doing all of this is too much work just to render one thing. The VO remembers all of this. It remembers all of this. And we just have to bind or unbind it. When it's time to render, we are just using the VO, which is a variable. It's a variable in our program. The VO allows us to not have to set up all of this every time. That's its main purpose. So when it comes time to rendering, we just bind the VO for our rectangle. We draw on the screen and we unbind it. And if we want to draw something else, we just copy this and paste it. And here, for example, circle VO, if we had set up before a circle. And that would be enough. We don't have to go over all of this again and again every time we render. That's the job of the VO. And now for the shader program. Yeah, that's for the VO, VBO, and EBO. Quite simply explained. And it's mostly what I know. I don't know much more than that. For the shaders, there's a really cool graphics and that explains the shaders. Shaders, I think. Where was that cool graphic, man? Oh, here is that thing where I explained the stride. And here he just uses positions and colors. But I used texture coordinates as well. You can write whatever you want in the vertices array. And here we can do this as well if you want. Where did he give the graphics? I assume the author is a he. Where did the person? Where did he gave a really cool okay, this is it. This is for the shaders. Like when I started learning all of this, I had no idea of any of this. Like I was really confused on what's happening. But with time and practice, you get the hang of it. So the shaders, all of our data that we have, all of our, like this is the data we're working with. All of this data, we're sending it off to OpenGL, and it goes through different processes. The first one is called the vertex shader, and the other important one is the fragment shader. All of the others we are not touching. We will not touch at all. Geometry, shape, assembly, rasterization, we are not touching at all. The vertex shader and fragment shader we have to build on our own, but geometry shader, shape assembly, the other parts, they have some default implementation. But for vertex and fragment, we have to tell OpenGL what to do. In the vertex shader, we take as input. In the vertex shader, we take as input the position coordinate, and all that we're doing is set the position of the vertices. So the simplest vertex shader is just takes position values and just outputs them. That's the goal of the vertex shader. It outputs and it goes through each vertice. So if I start the program, it goes through each vertex. So here this is a vertex, this is a vertex, this is a vertex, and here there are actually two vertex. I think two vertices. And here is a vertex. And we give OpenGL this vertex. It's a position. And the vertex, and here we give it in here. The vertex shader works with one vertex at a time. We have no idea what's happening with the other vertices. We are one vertex at a time. And we have to output, we get a vertex position and we output a vertex position. The simplest vertex shader outputs the same position it gets. That's it. This is the simplest vertex shader. But we can do cool things with it. Here, in the vertex shader, we can decide what to do with them. We can change them. The simplest one makes no changes, but more complex versions make changes. And we will, and here, for example, one change we can do is to move around the rectangle. So here, instead of when the time comes to move the rectangle, and we have to move it if we want to have player input, we have to move it. When it comes time to move them, instead of having to change all of these vertex, instead of having to update this array to once again have to do all of this, instead of having to do all of that just to move one pixel to the right a vertex, we will multiply it by a transformation matrix. And we will not write matrices that they have built-in ones for rotating, for moving and for scaling up and down. And just by multiplying it with this, we move it around. And also, once the data for one vertex passes through the vertex shader, it moves on through the other shaders. It moves on and reaches the fragment shader. In the fragment shader, it has to output a color. But how does it get data? Because for vertex shader, we gave it data from here. We gave it data from here, but we're not giving data to the fragment shader. The fragment shader gets its data from the vertex shader, and we told it how. So here we got the color from the VBO. We got the color, and we're sending it through the fragment shader through this output of colors. Because this variable is of the same type and name as this one, they are linked together. This is out because we are giving outputting data, and this is in because we are getting data from the vertex shader. And just because they're the same type and name, they are linked together. So when we say here, set the colors to what we got from the VBO, here we now have the colors. And now we output the color for the vertex through this line. And here we're ignoring the colors. We are just setting it to the color red. But now we will change it. We will actually use the color we are getting. And here we set it to colors. And we are getting just red, green, and blue. So we need another one for the alpha. And I think this is it. Let's render it. Let's start the game. And this is what we got. Now we are getting the colors. How? Like, what are these colors? We're getting them from here. We're getting them from here, where this vertex is, which is the top right. The top right vertex is of the color red. Here it is, color red. Bottom right, here it is of the color green. So it's red, green, and blue is the color green. And bottom right. Bottom left is of color blue. And top left is red and green, which I think is yellow. And that's what we gave it. And all of these colors in between, OpenGL automatically sets, because here it's red and here is blue. So what should be the color here? Well, it's a blend of both colors. The more we are closer to the red vertex, the more here we get, the more red we get. The more we get closer to the green one, the more green we get. But if it's in between, for example, like this, really close to the green one, like new follower. Thank you for following, but I don't know what this is. Unknown man. Streamer bot. I don't know why we get an unknown. It is I, the captain of Crunch. Yeah. Wait a moment. Yeah. Hello. Hi. We're just going through some OpenGL basics. Do you like the chat below the screen I get? I made it yesterday, the whole day. It's a horizontal chat. I don't think anyone has a chat like that. I made it personally. It combines both chats from Twitch and YouTube. Yeah, I like the chat scroll. Yeah, it's super awesome, and I see it as well. It's on my screen. It's not on OpenGL. It's not on OBS. Where is OBS to show you? Yeah, it's not on OBS. It's not on OBS. This black screen is an actual program. It's an actual program. Let me change to standing. Like I'm really proud with the program with the multiple chats. Okay, so I just explained how OpenGL renders these colors in between, because we told that this vertex should be red, this vertex should be green, this should be yellow, this should be blue. But how do we get all of these in between? Well, OpenGL generates them on their own, because we're just giving 4 colors. We're giving 4 colors, but here they're actually like more than probably 4,000 small points that have to have a color of their own. And they are just automatically generated. OpenGL decides them. But if we set them to the 4 vertices to be the color red, the whole rectangle will be red. Let's just set it to blue, for example. Let's go to the code. Let's go to the code and let's change them to where? Okay, here they are. And let's change them to blue. So this should be 0. Red, green, blue. Yeah. This should be 1. This should be 1. Should be 0. Red, green, blue. Red, green. And this should be blue. And let's translate code. And now let's run it. Now let's run it. And we got we got a blue rectangle. We are quite far off of making a game. We're making the breakout game. Where's the breakout game? Here it is. Yeah, we went through the how vertex shader works. I think we went through most of it, but yeah, we're making the breakout game. Not text rendering. To the game, breakout. Yeah, we're making the breakout game. Let's go to levels. And this is what my current focus is. Our current goal, with the little knowledge we have, at least the little knowledge I have of OpenGL, the goal right now is to make all of these rectangles. It's basically all we need to make 2D games. That's my belief as well. Let's hope that I will make the game in time, because I'm almost at 2 hours in, and I have 4 hours limit. I really want to finish it in 4 hours. But it will be quite difficult. It will be quite difficult because currently, when I'm rendering them, the coordinates I'm using are in local space. Because that's one issue kind of an issue, but we can move around it. Just because I haven't, not optimistic you'll finish that time limit, but it's an achievable. Yes, it's achievable. I also am not sure if I'll do it in 4 hours, but I'm a bit ambitious. So I went through the tutorial and I haven't gone through camera. But in coordinate systems, I saw that there are different spaces like local space, world space. Local space means the origin is at the center of the object, and that's what we're working with. This is local space. And the issue is that like we are rendering our rectangle, but if we want to render another one, it will render on top of this one. This is an issue because we want to render this. We want to render the rectangle and in world space to place it here. World space has, let's say, origin here in the center. And usually matrices are used to transform from local space to world space here. And this view space, clip space, and screen space is for 3D. View space most likely. View space is just when we have the coordinates in world space. View space moves them again so that they're in front of the camera. But we're in 2D. We don't have to work with the camera. Then clip space just removes the vertices that are outside of what the camera sees. So if we have a rectangle that's right here, clip space will just remove it so that we don't render it. But this done kind of automatic. And then screen space translates them from in clip space. We in order for them to render, like we had them as between the coordinates we're writing are between, I think, -1 and 1. And when we move them around in world space and then in view space, they will be quite bigger numbers and different numbers, not between -1 and 1. So what clip space does, it brings them back to -1 and 1 and removes the ones that are outside our view. And screen space translates the coordinates from -1 to 1, translates them to the actual screen. Because when we render them, like we said that this is 0.5 on X and 0.5 on Y. But here this is actually the screen. So they have to get screen space is usually upside down, which is inconvenient. Yeah, I'm not that like my knowledge is really basic. Like I just know I know enough to render a rectangle on the screen. And I'm pushing myself now to make a game with the little knowledge I have. Because here they actually show how to do it. This is actually a tutorial how to do it. And you're doing well. Everything you said sounds great. Thank you. Thank you, man. Here, like I was going through this tutorial, like the basics. I was going through, and keep in mind that this is knowledge of about 2 weeks. Like this is 2 weeks of learning this tutorial. And after I went through this tutorial of the basics, I saw that there is a tutorial on how to make the whole game. And there they have a lot of complex things like creating a game class, creating classes for rendering textures, etc. They're making it quite complex, and I will go over the code at some point, but I want to challenge myself with just the basics that I've learned to see how far I can go. And then when I go through the tutorial, I will take in a lot more. I see this as learning a lot faster. I'm not in a hurry to go through the whole tutorial for what they have to say. And the encouraging thing they said here is that we have, what encouraged me to do this on my own is that they said that we have learned here, this teaches everything we need to know. And there are many ways to make the game. And I thought to myself, since I know everything I have to know, and since there are many ways to make the game, why don't I see what I will come up with? Even if it's the wrong way, even if I'm doing something wrong, at least I will learn a lot. That's my goal. I want to learn OpenGL really quickly. And the kicker is that the actual code is written in plain English. I have a video on my YouTube channel on how I made English as a programming language, and all of this code that we're seeing is actually plain English. All of it is plain English, which is works, and I made a compiler for it. I have a compiler that reads these English sentences and translates them to this code in C++ with the help of this on the right side. I just made the rules. For example, this declaring float array variable. This is what I'm working with. Here, every time I copy and paste this, or just type it, it will actually use this. But having them as just copy pasting of code is not helpful. So that's why I made it dynamic, where it has parameters, where I can input something and it inputs it for me. In this way, I'm allowed to type in English. This allows me to not have to look at this scary C++ code, and it allows me to more easily experiment and try out different things. And while going through the tutorial, I went through it with this thing. Let me switch to down. That's interesting, but reading and writing code is a skill you should develop, not avoid. Yeah, you're right. You're right. The goal for this thing is not to avoid writing the code. The goal is not to avoid it. The goal is to focus entirely on the knowledge of OpenGL and making games. To focus entirely on that. And once I'm comfortable, I can easily just move to this code and start and transition to just the code. And then when I transition, the only focus will be learning the syntax. And I will be so now, if I transition now to just the code, I will, when I see here, I have the knowledge of VBOs, VAOs, EBOs, I have the knowledge. The only thing that's difficult is the syntax. Like I'm organizing the parts of learning. I'm just putting off the syntax. But when my goal is to get comfortable with the knowledge first, and then the syntax. I can easily just move to the actual code. And I have to really hurry with this thing because I want to make a lot of progress with the game. Now I have okay, we have a rectangle now. Let me bring back our goal. Okay, I have a rectangle. I want so what are the goals? Now I can create a rectangle. I want to easily create one and decide if it should be orange, green or blue. So maybe I will create a class that handles all of this. Also to be able to say, to give it a position so that I can easily move it around, I'll just use the transformation matrix to move it around. But I think I have to abstract it away into its separate class so that I can just say render a rectangle that's here in world space, then render one here, and to be of color orange. That's what I care about, not the actual rendering and the actual movement. I want to abstract them away. So I think I'll need a class for that. And then we will focus on the paddle. Okay, the goal is to at least render all of these rectangles, and through, if possible, a stretch goal is to render the paddle and to be able to move it around. That's my goal for now. Like, I'll be streaming tomorrow as well, so it's not that big of an issue if I don't do it in one go. I'm just setting a goal like that to finish it in 4 hours, just because I want fast progression. So even for the class, like for the shader, it's all again in plain English. Here we create a class, it has public members, it has a variable, that's the ID of the shader, it has a constructor, and all of this in plain English, man. The annoying thing is that it's a lot of writing just for one class. I can easily just create it without writing in English. The compiler for the idea of coding in English is still in beta. I'm constantly changing how I use it because I want it to be of actual value. This whole thing I'm doing right now is just to test this coding in English, how valuable it is. And to take note of the annoying parts, to take note of the most helpful parts, so I can decide what is the actual purpose and what changes to make. For now, the purpose is like training wheels for riding a bike, is what I'm seeing it as. So should we create? Okay. How to call it? How to call the class? Like, what should this be called? Rectangle. Yeah. Rectangle. Or just a block. Yeah, just a block. Let's call it a block. Block.h.epp. This way of naming it, the compiler will just remove the .epp and it will create a block.h header file. I am not separating them in a CPP and in header file because of the way coding in English is bit annoying to write everything again and again. I'm doing it all in one file. Need to move this here. And what else? Here, this, and here. So this include current header file only once in compilation is just pragma once. Just pragma once. Include OpenGL, read and write to console. And working with, we don't need to work with files. And we create a class. Create class, and the class will be block. And public members. So what will the block have? ID. It should have an ID for the vertex array object, I think. What else? We should be able to, I think it should have a position. Let me get a spoon just so I can eat while coding. I have oat and yogurt. So it should have a variable of name VO of type. I think it's an integer. Yeah. Non-negative whole numbers. I haven't implemented auto-completion for the parameters, sadly. So what gets created is block.h. And this is it. And this is what gets created. What else? What else do we need? Yeah, constructor. Yeah, let's create constructor. But what will the constructor have? Okay, class name block. Parameters, we'll implement them, and definition. Okay, parameters and definition. Okay, for parameters, it will have okay, so we will give it coordinates. The size, we don't need to give it a size because all the blocks have the same size. We don't need a different size. We need to give it a starting position where it should render at the start, and a color. We have to give it a color. It will be RGB, but but what type should be the color? So the color is just 3 float values, but can we make it simpler? Maybe booleans or string, because the user yeah, maybe for yeah. No, it will be 3 separate float values, not an array. 3 separate float values. We'll see what's better. So parameter of name, yeah, but the position as well. Position should be X and Y value. So X of type float. Do I have floats as type? Let me open the rules. Do I have floats? I think it was at the bottom. Okay, let's just this is the easiest way to check float because I don't have auto completion. Float. I should take note of this and make an improvement where I don't have to look like, don't have to search like this just for that. Okay, here is declare a function, return type void. Where is this set float? Set float, return value type void. Yeah, type float. Okay. I have a type float. Because I was searching for the type because I write this as I have to define each one of these. So I cannot, for example, say for example, a boolean if I haven't written it inside my rules. Okay. So another parameter of y. And what else? Red, green, and blue. Red, green, and blue. And that's it. We don't need anything else. We don't need anything else for the constructor as parameters. And now we go into the definition of the constructor, right? Okay, so for the definition, we will... Man, this is so exciting, man. It's so exciting. For the definition, now we will focus on creating the VBO, EBO, and storing all of that in the vertex array object. And we unbind it, and that's it. That will be for the... Oh, we need the vertices as well. Yeah, we will create them once. Yeah, we'll create them once in the constructor. Need some water. Let me switch to this one again. Yeah, this should be fine. And just when I set it up, I have to stand up. Oh, come on, man. Stand up. Like this, I'm having quite a lot of fun working on this. I hope it's also fun to watch. How far are we? Almost 2 hours. Okay. Let's open this. Let's copy this creation. And let's move it here. Let's move it here. Okay. We create the VO for easy access. We bind it. Okay, we need the vertices. Declare float array. Okay, we need the vertices. We need the vertices. Create vertex array object. Create VBO. Bind VBO. Okay. Yeah. Create an element buffer object. Tell OpenGL how to form a rectangle and unbind vertex array object. And vertices. Okay, we have it. We have the vertices. We have set up the VO. The issue is that we are not. Oh, we need to use the color as well. We need to set up the color. Yeah. So let's go to the vertices and let's make another rule. Let's go to the vertices. We'll go to the vertices. Yeah. I was just checking if I'm still live. It will be quite a shame if the stream stops suddenly. And this is my first time multi-streaming. I hope it's properly working. Now. Yeah. We need to set up a rule for this thing. Let me increase it. Let's copy it, paste it, and let's change it to vertices with color values x red red, green, and blue, and texture coordinates. They're just whatever we have here. Yeah, so this is the red one. Oh, come on. let's change it to like this, and let's change it to red, and this to be green, and this to be, oh no, and this to be blue, right? And then we go here, and because our rule has parameters, we cannot use it now. We have to with value, we have to do it like this. Vertices with color values red. Oh, come on, why doesn't it? What? Why doesn't it auto? If it doesn't complete, it's bad because it it doesn't find it in the rules. That's why it's bad. What if I do it like this? No, it doesn't find it. Why? Let's do a test. Test. Oh, come on. Test. What? Test. Test. And now, does this autocomplete? Oh. I think I need to. No, I need to restart the extension. Yeah, now it works. The extension just it has a hard time working with multiple files. I have to fix that at some point. Yeah, so let me change this back to values. So vertices with color values red, green, and blue. What? Will this work? No. Oh yeah. Yeah. It works. Yeah. And that's it. Let me clean my glasses. Now we've created our vertices. We gave them to the VBO. We created the VO. We created the VO. Oops, sorry. What else? What else do we need? The position. We need the position. So we need the transformation matrix. we need a transformation matrix. And I need to sit down. We need a transformation matrix. Test. Why am I this far out? Oh, the camera is... What else? Yeah. Yeah. We need we need transformation matrix. We need a transformation matrix. Yeah. So we go where? Where do we go? Where do we go? Yeah. In the past example, so the test file. Where I wrote before working with matrices. So now. Oh, we just need to create the matrix. Because we are not, this is the constructor, we are not rendering anything. So let's create a net matrix. I'm confused. Oh yeah. Let's now create identity matrix. Oh, so this is GLM. Okay. I need this as a type, I think. I think I need this as a type. And yeah. I think I need this as a type. Yeah. We need to store this matrix. So let's just say matrix. It should give GLM 4. That's it. And I think I have to include GLM as well. GLM. And I have to make a variable of name transformation or just trans of type do I have it here? Matrix, yeah. Of type matrix. Does it work? Why do I have what? Cannot open source file. GLM GTC. Really? Okay, let's ignore it. But it has an issue here. Oh, come on, man. Come on. Why? I'm a bit confused on the include of the header file. let's open main CPP. Here it works. So it goes in GLM. Come on, man. I'm really confused, man. Include GLM. Cannot open source. Okay, let's compile it. It's compiling, but yeah, it may be just an issue with VS Code, thinking it's an error, but it's not. Now let's include it. Let's open the rules. Where's shader? Let's include the blog file in our code. Okay, yeah, include call from personal file block h. And now here it is. And now let's compile and see it compiles. Okay, so most likely it's just because I'm coding in VS Code. Next, yeah, now we focus on the transformation matrix. It's in here. No, it's in test. So, transformation. Now, create where is this? Create entity matrix. This creates a new variable. That's an issue. Do I have set value? Do I have set value of a variable? Identity matrix. We will create new rules. It's this thing. Oh, come on. Identity matrix. We don't need this at the end. And set a variable name value. It's name equals value semicolon, and now we do set variable. Come on, man. Set variable. Oh, I have to restart extension. Rules EPP set variable name. Oh no, set set variable a value. Yeah. The name is transformation matrix. Of value, we will set it to the identity matrix. To the identity matrix. Here's the constructor, and here we set it to the identity matrix. Next, what else? Because we're doing all of this because when we set the x and y values, I want the block to move there. I want the block to move there. When we set in the constructor x and y, I want our rectangle to render on that x and y. But so it should be the transformation matrix should be all transformation matrices start with the identity matrix. They all start with the identity matrix. The identity if we what we will do is in the vertex shader we will multiply each vertex position with the matrix, and the identity matrix does nothing. It keeps it at the same spot. It's our starting place, and we will build upon it more advanced transformation matrices. Right now, we want to, I think, we also have to scale it down because, right, you know what, let's, yeah, let's use the translate matrix by, and here it will be x and y. So right now we created the identity matrix and we multiplied a translate matrix. You'll see. But right now, when constructing the rectangle, it will, when it renders, it will render it at a different position. What else? Where do we use it? We use it as we will set the uniform. We'll go over what uniform is. We'll set the uniform and that's it. Yeah. And okay. And finally, we will have a render function. We will now make a render function. We have written enough. We will make the render function. Let's write a function. We will call that function with the shader. And we will, when the function is called, we will render on the screen the rectangle. So we need a function. Yeah. Man, this is so annoying, this error message. We need a function name render. with arguments return type void, and definition we will set it. Arguments and definition. What's the time? Okay, 2 hours and okay, less than 3 hours. So what will the rendering will need parameter of name shader program of type. The type is what I am not sure about. Does it have to be a pointer to the, because I have a shader class. I have a shader class and I'm giving I have a shader class and I'm giving it an object of that shader class. I know that in C++ there is pass by value and pass by reference. Pass by value, pass by reference, class object. So. Okay, we declare a class. We pass by value, so it copies it. Pass by pointer. Appoint a special type of object that has the memory address of some object. So I think it should be reference. I'm not sure, man. Yeah. I think we just have to have this reference thing. Yeah. This right here. So we need to create a rule. But how do we call it, the rule in English? We have pass by reference. Think of a reference, a variable, as another alias for an object. It's a second variable name for the same object. So what should be the type? Yeah, reference to... Yeah. So we will create a rule. Reference to type. And it's type and that symbol. What was that symbol? I think this symbol. Where was it? Where is it? Yeah, this. So when we set up the parameter of type, the type will be reference to type, I think shader, right? Yeah, shader. Yeah. Oh, the definition, we need a definition. We need a definition as well. Have to stand up. Um, 2 hours in. I think I... Yeah, okay. This side is too strong. Man, it's so low quality. Not sure why. Okay. Right, the definition. The definition. So for when we're rendering. For the definition, where was this? Yeah, test. Okay, so when we render, what we want is to activate the shader program. We activate the shader program. We no, not mix amount. We get the uniform and set the uniform. Okay, I'll go over uniforms. Store in new variable, transform location, set uniform. Okay, nice. Then we bind a vertex array object, and then we draw the rectangles and we unbind it. This should be enough, man. This should be enough. But we need also to update the vertex shader because I deleted the multiplication with the where was it? Resources, vertex shader. I changed the position. We will multiply it by the transformation matrix. I'll go over that, but first I want to see if we can get it to render. Oh my god. I'm nervous if it will work. Okay. Now we go, where do we go? We go into the main file. We go to the main file and what do we do here? We've included it. We will delete this. We don't need it. Did I unbind? Did I unbind here? Yeah, I unbind. And we will delete this. Now we should get an empty screen when we render. We should get an empty screen. Yeah, an empty screen. Now let's create a rectangle. Man, Let's create a rectangle. Dude, have no idea if this will work. Create shader. So we will have create create block. Create block. Create block. Oh no. No. Oh, come on, man. Why? See? Block name. There, finally it worked. Width, and what were the okay. So we create a block. We create a block, and here we set what were the parameters of the constructor? Okay, we set the X with position. Okay. With position. With position X, Y, and color red, green, and blue. That's it. And so here we say X, Y, red, green, blue. That's it. So now let's create it. Create block. Let's call it test block. With position, let's leave it at 0. Is it a float? Was it? Oh yeah, float. But where do we use it? Transformation matrix, translate. Okay, and how did I use it? Yeah, without the F. Why? Translate matrix. So in rules, translate matrix. I think it can handle if I type it as 0.0f. I think it should be like this. And color. So let's make it red color. Green should be 0. Blue should be 0. And here we have to render it. So render block name with shader program. So it's block name render shader program. Have to sit down. Let me leave it as this. Be back. I'll be right back. I'm back. I'm back. Okay, sitting down. Let's do this. Now we will test if our code works. If our code works and if the rectangle actually renders. One second, just to get in position. Okay, I'm ready. Now, does the rectangle render? We have to go here. And what else? We have to... Yeah, we have to... Where was it? Here. Yeah. In the main function. We render block and the name of the block test block with the shader program. Are we going to do it, man? Oh my god. And let's see. Build failed. Oh no. Build failed. There is an error. Oh yeah, render. Render. What's the issue? What? Render. What's the issue? Oh, the function is not generated. Why? It should be able to. What? Let's restart the extension again. Let's translate the code. It's not. Usually this is because some kind of mistake. Let's do it like this. Function. Render. Arguments. Type void. And definition. Like this. Why is the function not compiling? Where is the issue? Return value type. Arguments. Let's simplify this. Still not working. Let's simplify this. Float. Still not working. Arguments. You know what? Let's test out by removing all of these. Simplify it like this. It works. It works. So the issue is somewhere else. The issue is maybe in the yeah, let me delete this as well. I have confidence in the compiler. Like, I worked a lot on it. It should be able to handle this. Oh yeah. I understand now. It's just because of the tabs. Should be one tab below. Yeah, now we have it. Okay, we translate this. Now we have it. I figured it out. And come on, man, nothing is rendering. Why nothing is rendering? Now this is really confusing. Why is nothing rendering? Nothing is rendering. Oh, is it because of the transformation matrix? Because of the position? We are having the same issue as before. Most likely the transformation. You know what? Let's simplify it. Let's go to here and remove the movement. And let's run it. Why is this still has no member render? It has a member render. Let's run it. Okay, it still doesn't work. Let's try something else. Let's go into the shader and remove the multiplication. Let's remove it and let's try again. Still nothing. What? Oh, maybe. What? I'll keep it like that. And let's go into the fragment shader and set it as just one color. The color green. Still nothing. Let's... we have to just see what's wrong. Okay, now we create a block, test block with position and color that we ignore, and we render it. That's what we're doing. Is it having a problem with the shader? Like the reference with it? It should be working. That shouldn't be an issue. Block H. So we have a VO. We have a transformation matrix. Thank you for following, but my My notifier struggles reading names. Yeah. Hi, Luna. How are you? I'm fine, doing fine. Do you like this? Do you like this chat at below the horizontal chat? I worked on it the whole day yesterday, just to have it. Good to hear that. It takes chat messages from both YouTube and Twitch. I'm from Bulgaria, from Eastern Europe. Now, I'm trying to debug a problem. I'm trying to render a rectangle, but for some reason, it's not rendering. Nice to meet you. Which game do you stream mostly? I am just stream making games. I mostly stream programming. Right now, I'm trying to render a rectangle. When rendering without an engine, even just a rectangle is difficult. So let's debug what the issue is. We set the transformation matrix, but we ignore it because we've simplified it a bit. We declare the vertices. Let me open the actual code. Yeah, we declare the vertices. They look fine. The colors should be fine, yeah. How for me share it? Actually, no. Not looking into offers. Okay. We declare the vertices. All right, no problem. We create the vertex array object. We bind it. We create the vertex buffer object. We bind it as well. We copy the data. We tell it how to interpret the data. We create element buffer object. Tell OpenGL how to form rectangle. We provide vertices. And we'll unbind. Okay, that should be enough. And for the rendering, we activate the shader program. We set the uniform, which we ignore in the shader. We bind the VO, we draw it, and unbind it. Let's look at the draw triangles from EBO. Yeah, it should be all right. So what's the issue? Let's check if we do this, if this will make a change. I think it's already doing it, and this will not make a difference. Is the same. The issue before was the transformation matrix. What am I doing wrong? I'm quite confused right now because we should at least get, if the shader is not working, we should at least get a black rectangle. But since nothing is showing, we may have a mistake even before that. It's difficult for me to figure out where the mistake is coming from. It's difficult to figure out where the mistake is coming from because nothing is showing on the screen. Absolutely nothing is rendering. And there's nothing in the terminal. So what's the issue? What's the issue? Before it was before we had the same issue because in the vertex shader we multiplied by the transformation matrix, which was probably initialized to just zeros and made all the vertices as zeros. I'm not sure how to tackle this. Oh, come on, man. So where could the mistake be? We have our object, our block object, and it has the ID of the VAO, and it has the transformation matrix. The transformation matrix, we currently ignore it. The VAO, we bind it. We bind it. We create it. Bind it. We create the VBO. Like, what's the issue, man? What's the issue? Have to change pose. I'm really struggling to figure out what's happening. We may I may just try. I may just try to simplify things, just to figure out, like, to I may just test different cases to figure out where exactly the problem is happening. You know what I can test? Yeah, I'll test something. I have an idea what to do. I'll be right back. I'll be right back. I'm back. I'm back. My idea that I want to try is to check if I'm passing the reference of the shader program properly. I'll test it with the uniforms, and this is a perfect time to explain about the uniforms. So uniform is this right here. Like our variable is a name and type, and when we say uniform here, this means that we can set it in our code globally what this should be. So what my idea is right now is to set a float uniform float. It's globally, because it's global, we can even set it here in the fragment shader. Uniform float test, and let's set this this to 0 and this to the test value. So we will set the uniform here in the render. Activate shader, get uniform. Where did we... where's the set uniform? Yeah, I'm looking for set float uniform. Yeah, okay. So we will set float uniform name. It's called test of shader program to value 1.0. Okay. So now we will do an experiment. Let's stop the render. Let's take out declare float. Are we declaring it here? Are we declaring it here? Float array vertices. Okay, we have vertices. Let's copy this. Oh my. Oh my. The issue is my English programming language, because create vertex array object creates a new variable called VO and probably doesn't set this one. Oh my. Man, this is so infuriating, man. What? If this was the issue, man, this would... If this was the issue, man, that would be just... create vertex array object. Create a vertex array object. Yeah, it creates... yeah, okay. So we need a new rule that doesn't Yeah. So no, we can leave it as one row. We'll just remove this one and change it to not create vertex array object. Yeah, with name create array object and store in. That's what we'll call it. And we will delete. Oops. Delete this. That's what we will do. And so here, instead of create, we are, yeah, it's create vertex. Vertex array object and store it in view. Man, if this was the issue, that would be so... Don't tell me. I hope and pray that this wasn't the issue. Because if this was the issue, that would be so infuriating and a bad... and it would look bad for coding in English post. Oh, come on, man. Oh, come on. Oh, come on, man. That was the issue. Why? We finally solved it. We solved the problem. Oh, come on, man. We solved the problem. So let's remove this uniform. Let's open the vertex and fragment shader. Yeah, I have to sit down. Okay, we are quite close to rendering levels. Quite close. We have little bit more to do and we're done. Little bit more to do. So let's bring back how it was before. You can hear me? Test? Yeah, everything working correctly. So now I want to also change one other thing in my chat application. In my chat application, I want to just see for followers. First words, follow, new follower, data. Oh, what about chat? Because when somebody follows, it says unknown. It's not getting the name properly. Chat message. Yeah, okay, so here I think it's username. Let's leave it as that. And let's restart the server. Okay, I restarted the server. Let's do... Oh, come on. When did you write those messages? When did you write those messages? Are you here? Oh. Oh, come on. Why did only you... Yeah, yeah, sorry. I'm seeing that there are YouTube messages that... Yeah, so why are not YouTube messages showing? Let me just do test. Okay, Twitch works. Does YouTube work? YouTube doesn't work. Actions, commands. No, it's platforms. I think YouTube. It's not connected. Oh, I see. I see the issue. 1 second. I see the issue. Let me bring up the chat for you guys. Sign in. Yeah, now YouTube works. Now YouTube works. I missed some YouTube messages. Oh, come on. I'm so... Okay, let's... we missed some YouTube messages, but... Like... I couldn't... I didn't know it had that issue. Okay, everything is fixed. We can move on. We can move on. Let me pick another audio. So now let me also write YouTube chat now works. Okay. Now let's go here and let's set the colors. Now we are setting the colors that we're getting from what we set here. Here, so it should be red now, not blue. Now we should get where was it? Yeah, let's go to VS Code and let's start this. And here we have a red one. Good. Now let's see the position change. Let's do the position change. Let's see here in the vertex shader. Let's multiply by the transformation matrix, and let's bring back the transform. Translate matrix trans by x, y, and here 1.0. So now we should get the same. We should get the same result because we're not moving it. Here we're not moving it. Now let's actually move it. Let's move it here. So now we are spawning the block at 0, 0. Let's move it at the top of the screen, which is left. Bless me. So it's the left side. So what's that? So minus 0.5. Yeah, that's to the left is negative. So 0.5. And let's move it to the top. So here 5. And now let's render it. Let's render it. And here it is. It's on top of the screen. Now let's make it actually smaller. And let's make it more of a rectangle. Or should I leave it as a square? I'm not sure. I'm not sure. So the vertices, where are they? So the vertices should I make it or should I keep it as a square or make it a rectangle? So this is top right. Top right can be, yeah, top right can be 0.25. Bottom right minus 0.25. Yeah, just keep the height lower. And we translate it, and we let's start it. Here we have a rectangle. Yeah, perfect. And now let's scale it down. Now, what was the order of things? Which was first? Because the order is really important. Scale, translation, no, scale, rotation, and then translation. Because in matrices, the order of multiplication matters. The translation movement is the last thing we do. Yeah, let's so yeah, we can scale matrix by, and let's scale it down 0.5. Let's scale it down. And let's see it now. Let's see it now. And here it is, it's scaled down. We need it smaller, I think. Let's see the... here. Oh, we are almost 3.5 hours in, and we're still quite far off. Okay, so we need to fill in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We need to fill 15 rectangles. So I need to make my rectangle a lot smaller. I need to make it a lot smaller. I need to make it a lot smaller. How much? Not sure. It would be the easiest to calculate it. So x goes from... Okay, we can try to calculate it. Let's open the whiteboard actually. Let's open a whiteboard. So now it goes from -1 to 1, the x coordinate. Why is the light flickering, man? Why is the light flickering? Okay, it goes from -1 to 1. We want 15 of these rectangles. We want 15 rectangles. Right now, the size of the actual vertices are from 0.5. Okay, they're a 1. So they fill half the screen without scaling down. They fill half the screen. And we want 15 of them. When I made it half the size, it would fill, it can fill 1, 2, 4. It should be able to fill in 4. So this thing should be able to fill in 4 times. Should be able to fill in 4 times. As it is right now. Oh, come on. Yeah, okay, so 1, 2, 3, 4. Okay, it's 4 times right now. Okay, my math is kinda correct. And we want it to be 15 times. What if I... I want it to fill 15 times. Okay, so I can make it 16 times, I think. I can make it 16 times. If I keep dividing by 2. I can make it 16 times. I can make it 16 times. I can make it 16 times. Uh, 16 times. So here, where I scale it down by 0.5, I should scale it down again and again and again. What if I do it like this? Like 1 divided by 2? Can I? Oh, come on. Can I make it like this? And here like this? And let's change it to 1/4. This is easier for me. And let's compile it. My Python thing hit. Did I have to change to standing up. Have to change to standing up. Stand up and be right back. I'm back. I'm back. Where's the music, man? Where is the music? Oh, there's music. What did we test now? If it's 1/4, it's not working. 1/4. Where was? Yeah, 1/4 doesn't work. Block H. Yeah, 1/4 doesn't work. Why? If it's F, no. What? Shouldn't it be able to work? I really want it to work. Okay, 0.5. Okay, we can 1/4. Okay, we can do, we'll just calculate it. So how many times do we have to do it? So at the start, without scaling it down, it can be fit 2 times. With scale down, like this is at 1, with 0.5 we can fill it 4 times, then 8 times, then 16 times. 0.25, and this should, like this is 1/4, and this should be 1/8. How much is 1/8? 0.125. Okay. 0.125. Okay, now this should work. This should work. Start. And here it is. I should be able to fill in 16 of these. Should be able to fill in 16 of these. I also want to pick the right color. From here, let's print the screen and let's open Krita. And these are all my thumbnails. New, create, paste. Let's see what the color is. Let's pick color picker. Where's the color picker? Why is this hiding again? Color picker, crit. This works, right? Yeah. Krita, where's Krita? Okay. Color picker. This and this and that. This is more of a gradient. This is more of a gradient. Okay. But these are direct values, not as a point, because we need a float, not like this. So I have to divide it by 255, I think was the max. So 0.7 red, 0.7 red as a color. So 0.70, and for green it's 35. For green is 35. And now let's see what color we get. Kinda the same, it's just not a gradient. I don't know how to work with gradients. Oh, I found this. This is from Crit. Oh my god. So the next one. Yeah, let's do this as well. Oh, come on. Can't I? Okay, 148. I get an error. Streamers bot YouTube quota has been exceeded. What? At least do I have a stream? That's what I want to know. Yeah, stream is live, so only Twitch chat will be below, I think, because some weird quotas. Platform, YouTube. Yeah. I see. I see. Very weird issue. Very weird issue. Okay, let's open back up 148. 148. 58. All of this is just so we can get colors. We will have another block, test block 2. And we will render test block 2 and test block 3. And we will have this at the center. And this one will be let's move this one also at the center but to the left. This one will be to the right. And the colors, this should be 58 from the calculation. This should be 58 and this should be 74, but here 74. 74. Uh, 29. 29. And the green one. Now let's do the green one. It's 128 green. Or 133. 133. The rest are zeros. So 52. Should be 52. This should be 52. This should be a 0 and I need another block 4. I will move it more to the right, like 80, for example, to the right, and let's render it as well. Oh, come on, why did I close it, man? Need music. Okay, need to sit. Sit down. I think the music is quite low audio. Yeah, music is quite low. Okay, let's render these triangles. How are we with time? Okay, we have bit time to render everything. We have bit of time. So let's create this block. Let's move it here. Let's render it, and let's what else? Yeah, we have to pick the color. We have to pick the color. The blue one has a lot of values to fill in. So red, green, blue, okay, 14. 14. 14. 112. 112. 43. 43. And the blue 186. 186. 72. 72. And that's it. And so now we what do we do now? Yeah, here, and we start, and this is what we get. These are all the different possible colors, and we will do 16 of them. We will do 16 of them on each row. 16 of them, and now we just have to spawn them. We just have to spawn them. How do we get the left side? How can we? There is some other issue. Like, it's best to use an array here and a for loop to first create them and then render them. So what's the issue? What's the issue here? So what I want right now, what we need right now is to render them from left to right, and we will need to render a lot of them. So there are 16 on each row, and there are 16 on each row, and there are 1 2 3 4 5 6 7 8 rows. So 8 times 16, yeah, a lot. Maybe more than 100 variables, which is not ideal. How can we simplify this? How can we simplify this? How can we simplify it? Because for each rectangle, I have to create a variable and say that that variable should render. What is this music, man? How can we do this, man? How can we do it? We have 30 minutes left to finish this. How can we do it? What I want is to... What would be the best way to do it? If maybe it reads from a string, or maybe we use an array of rows and columns, and it goes through each one, and if it's a true, it renders there. No, it should be an array of blocks. And we go through with the for loop, we create, not variables, but array of blocks, and we go through, we initialize it of size like 8 times 16 size, 8 times 16, and we go through it. We go through it and we initialize a block for each space, and then in the rendering we go through the array and render each block. Yeah, that's it. That's what we're going to do. Should it be to the array? No. And 2D is a bit complicated. And if it has nothing, like the spaces where it's empty, it should be without a block. But no, it should be an empty block, so it actually renders nothing. That would be quite useful. An empty block. Empty block. So if it's an empty block, it just keeps everything. So another constructor and empty blocks just But what about collisions? How do we tackle this? You know what? We can simplify it because I'm struggling the most making it here making it here empty. But we can simplify it and just fill out all of them to be the same. That would make it a lot easier, and this way I don't have to worry about empty blocks. Yeah. So that we don't have to worry about empty box. How are we with the time? No, we're not good with the time. But if we wanted to have empty blocks, one way to do it is with just the array to have yeah, we could have another field for the block, and to decide if it should be rendered or not, that should be an empty block. So we can fill out all of these, and for these ones that are empty, we can just say that those should be should not render when we call the render function. So we should make them invisible in a sense. So when the render function comes, it just skips everything, but it has the VO setup. Yeah, that's what we're going to do. Yeah, it will be an array. Let's do an array. Let's do an array. Let's do an array. And before that, let's see. Let's move all of these down. I want them to be down, like minus 50. Young side. Mm, 50. And let's check it out. We move them downwards. Yeah, I move them down so that they're just as reference. I don't want to delete the code just yet. And so now what else? We make the array. We declare, yeah, even this we have to change. Declare float array. It's declare array name of type and value. So it's type array name equals and what about the value? No. It should be and size and size. Size. I think here is where we put the size. Yeah, we're just declaring the array. So here we declare array blocks of type block and size. What should be the size? So what's the count? So it's 1, 2, 3, 4, 5, 6, 7, 8 by 16. So 8 times 16, 128. 128. Okay, we have an array. So now we need a for loop. We need a for loop. We need a for loop. We need a for loop, but I need to create a rule for the for loop as well. So let's find C++ for loops. For loop. This is an example for loop. Now, how do we call it? For this many steps, execute block of code times many times. Execute this block of code this many times. Yeah, execute, and this should be the block of code, and this will be the amount of times we executed. That's our for loop. Next we declare the array. Next we execute the block of code. How many times? 128. And the block of code is the block of code. We should initialize, we should create test block. Create block. Yeah, but we also need to set the value of the array. Let me look up C++ arrays. So we need to set the value. We need to set the value. Set to change to stand up. Set array name stand up. Okay. Test. We need to let me check the volume. Yeah. Set. We need to set what? I see you fixed the YouTube chat. I did fix it. I did fix it and it broke again because of StreamerBot. Because of StreamerBot, here it logs me off because of an error. Like I can sign in and now it should work. Test. Now, yes, now it works, but limited amount of times because of API restrictions. It's not coming from me, the issue. It will manage to show a few messages and then it will stop working, but the Twitch one should still work. Like, I haven't checked on them. I hope it works. Test. Yeah, Twitch chat works. So I have on the second monitor the YouTube chat and I'll just check it from time to time. I'm very disappointed at this. So set array. Set array. Yeah, I'm sad too. Set array at element at position value. So here is the position and here is the you asked me what do you think about DeepSeek's new AI? I'm quite surprised at how much they achieved with I think only about $5 million. I've tried their product, their chat. I think I can pull it up. DeepSeek. Start now. Introduce yourself and with deep thinking. And here it actually thinks and it shows what it's thinking. And it's really good. It's really good. And the only limitations is that a lot of people use it at the same time and the server cannot handle and it just stops working. It's not because you don't have any more trials. So I used ChatGPT. My free trials ended because the free version is quite limited. And so I decided to try DeepSeek, and DeepSeek managed to keep up the high quality of ChatGPT. The quality is really good of DeepSeek, and it's like it took the world by storm. Even the news are talking about DeepSeek. DeepSeek is really cool, and I was thinking to make this stream about DeepSeek, where I compare DeepSeek and ChatGPT, but I'll do it on the second stream. The reason I didn't want to do it today is because of the server load. If I can't access the server, then I'm currently downloading R1 to try it locally. I prefer local file versions of... Yeah, I also... Yeah, but how many parameters is your version? I know that there are smaller ones and quite bigger ones. How big of a local model can your machine handle? Like I think there is a one is there I think there's one where it's about 1 billion parameters, one there's about 7 billion parameters. Not quite sure about it. I also came up with an idea for a project using DeepSeek offline, like you're using it offline, for helping with coding. I hope I'm downloading the 7 billion one. I hope you can run it. I also want to download an offline version and create a programming partner that you code together, but that's an idea for another time. Okay. Value, position. Okay, array name. We have to change the array name. I really have to focus on the game because I promised I would have some kind of progress in 4 hours. And we are almost 4 hours in. I have to lock in, man. I have to lock in. I have to lock in. Okay, so what we're trying to do now is render all of these blocks we are trying to render, and I'm first going to store them in an array. So we will set array. What was the name? Blocks at position I because of the for loop. With value. Value is we create a block. Yeah, but we do create it, but it's quite different. When creating it like that as a value, there shouldn't be a block name. Create block, yeah. And we can just do it like this. This will be the rule. And here we can say block with position. Now, what about the positions? Let's start them at minus 0.5. The y will be the same for now. The y should be the same. Yeah, let's keep it at 0 on y. And the red, let's have it the first one. I should have hard-coded the colors, I think. It's annoying to input them every time. Green value is this, and blue value is this. And let's bring down the numbers to 16. For now, let's just have one row. And here for the position, it should be plus. I'll be right back. I have to change position. I'll be right back. I'm back. I'm back. Sit down. Okay. I want to, before ending the stream, I want to at least render the one level and maybe have the paddle working. I really want to achieve this today. Here we can, the block positions should be dynamic. Okay, let's try this plus I times 0.5 or 0.10. And let's see what this will bring. Oh no, there's a build error. Okay, we have no default constructor. Oh, we need default constructor. Oh, come on, man. We need default constructor for each block. Yeah. That's quite sad. That's quite sad because I would have to change the code a bit. Have to change the code a bit. Default constructor. Default constructor for class name, and it's class name like this, and definition but I want to reuse the other constructor, C++ default constructor, reuse constructor. Where is it? I think this is it. So we have defined, for example, this one with parameters, and for the default one, we're telling it just use another constructor with these values. But how will but the problem is I have to create, I'm writing in English, so I have to create a rule for this. Everything that I use has to be explained. And it's helpful when learning something new, but it's not helpful when creating things we already know. It would be a cool feature would be to be able to use English and coding at the same time. English and code. Okay. So there is a default constructor, but we wanted but we want it to be test. Okay. We want it to be so it does this. class name and parameters. Yeah, here are just the values. For class, and the definition that calls another constructor with arguments. I think it's arguments when you're giving values, and when declaring it's parameters. Arguments, and we need to separate them with commas. Arguments, definition. What else? What else? What else? What else? Okay, so now we need to define it. So constructor for class, constructor for class name. Okay, I need to restart the extension, and I need to translate this, and it's still not what? It's default constructor. Default. Yeah. Block. Definition, I leave it. And arguments, we will use default arguments. The default arguments will be 0.0f, 0.0f. Color is, oh come on man, the default and color should be, default color will be black. And can I make the definition empty? Yeah. So this for the position, this for the color. And this is the default constructor. The issue, oh my god. The issue is that I've set the color in the vertices, and once set, I cannot change them. Once they are set, I cannot change them. Like, I can change the matrix. I can change the matrix, but the colors are, oh, I can, you know what, I can make them the default colors white. I can make the default colors white. Default colors white. One, I can make them white. And I have to create a function for but if I create a function to change the transformation, I need the shader as well. I need a shader as well. So it will. So function. What will be the name? Set location with arguments and return type void and definition. Definition should be no parameters. We need parameters. Why is it not working? What? Arguments. No, what? Arguments, parameters. I got them really confused. No matter. This is not a priority right now. What will be the... So we need x value of type float and parameter of y value of type float. And in the definition, we will update the matrix. We will update the matrix. Yeah. We update the matrix to be the new x and y values. Color. The color, it should be it should be just one float value. Okay. Oh, no. No, it doesn't work like that. It should be x, y, and z. It should be x, y, and z. How can I send... if it's x, y, if it's red, green, and blue... let's have them as 3 separate floats. Variable red of type float. That's what I know, and that's what I will do. This is green and this is blue. And here we create another function. What would be the name? Set color with arguments type void and definition. Arguments and definition. So here we need a red float, green, blue, and here we just set variable red value value, value, and here it's red value, and this is green, blue, green, blue. We update them, and in the rendering we will have a uniform. Yeah, let's go to the fragment shader and have uniform float red, green, and blue, and let's have colors dot red times red colors dot green times green colors dot blue times blue. And here we will set the uniforms. Set float uniform red of shader program to value red, and here the green, and here the blue, green, blue, and that's it. And now we have a default constructor. And this time just now we want to go through each of them and change the position and color. Man, I'm nearing 5 hours. Let's change the position. Okay, we change the position by accessing that block. So we need to access array element at position we access that element, but we need to call a function with parameters. We need to stand up. We call the function. Okay. We got it right. Array name of position, and here call function name of variable with. So now is it parameters or arguments? Parameters. No, let's call it arguments. So it's variable function name arguments. And here we block of codes, we call we call function name, yes, of variable, etc. So we call, I think it's set position, set location, and set color. Let's do it as set position. Set position. Let's stand up. I'm standing up and down constantly because of herniated disc. I cannot, if I stay more than 20 minutes, it hurts a lot. Test. No, right now it's really quiet, I'm sure. Test. Now it should be fine. Now it should be fine. We set position. Yeah, I think it's set position. Okay, so now call function set position of variable. We will set it with arguments. So the variable is axis array blocks element at position I. That's the variable, and arguments is 0.5f plus I times 10. What? Oh, I didn't do any variable. Yeah, it should be like this. It should be like this. Right? Let's render it. Let's run it. What's this music, man? And let's see what it created. It should create in main CPP for loop. Yeah, set position. What's the issue? Oh, it doesn't have this call function. Translate. Okay, so now set position is left. Position. I haven't compiled it, I think. Now the blocks. Yeah, because weird. Let me fix those other blocks. Let me fix those blocks. Block. Where is it? Colors. Yeah, let's go down here where we... Oh, we didn't set the colors at that place. Red, green, and blue. Like this. And here, value, value, value. And here, value. It's okay like this. Now we should have... Okay, we brought back the colors. They work. Where? Are they darker? I think they're darker. Oh, I think they're inverted. Let me go into the... Yeah, I think they're inverted. So it should be... so there... So it should be 1 minus this. So red should be 1 minus red. So this green and this blue. And this blue. Now they should be fine. How are the... Oh no, man. What? Oh, this is single one. Oh, maybe there's an error. There's an error. Assignment to uniform red. Assignment to... Okay, maybe we cannot assign to uniforms. My bad. My bad. So we'll just... let's do it like this. Here. Like this. 1 minus... 1 minus... Now it should work. Now it should work. No, they were fine. They were fine. They were fine. Okay. They were fine. Let me see why. Oh, we're not rendering them. We're not rendering them, man. Let's go through. We're not rendering them. I should sit down. We're not rendering them. Execute like this. We're not rendering them. So execute block of code. Let's render all of them. 100 and how many? 28. 128. Call function. Render a variable accessory block at element position I with arguments. See inside shader program. Now we should see those things. This is what we get because we didn't set the color, and There's no spacing between them. So the starting look, okay, this is good sign. We also need to change the color. Call function. Call function set color, and the color will be 0.70f, 0.35f. This should be it. This should be the color. And we start the game. And here it is, but why is this one white? Oh, because they're rendering on top of them, the others. The others are rendering on top of them. So we will only render the 16. Only render the 16, and let's start them from where? We start them from -1. Let's start them from -1. Now they're too far on the left. And I also want, so this plus, let's make it plus 20. Let's make it plus 20, just so there's bigger gap between them. Now there's gap between them. It's too much. It's too much, so let's do it 15. 15. This is 15. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15. They should be 16. Let's try 12. You know what? Let's look at the size of each one, how much it is. So it's, oh, it's 0.25. Yeah. I think it's that. Yeah. Perfect. And let's make it a little bit bigger. I made it bigger, but not enough. Why is it like that? Where at some places it's perfectly together, at others there's a gap. Oh yeah, I have to sit down. Okay, test. let's do it big more space between them. Let's render again. Here it is. Why is it that at some points there's more space between 1, 2, 3? Okay, these are all the blocks. These are all the blocks. These are all the blocks. Now we want the starting point is too far left. We have to make it this 0 and this like it should be 1 minus, it should be this thing. And a minus. Minus. Man, this is so... I'm sure I'm not doing it the right way at all. But this is the way to learn, by playing around. And here it is. The only thing I'm wondering is why is it so that between some of them there's little bit of space and between others there's a lot more space. Why is it like that? It's one. When we create them, each one we set its position to be at this times. Oh. Okay, because of the way I'm doing it, it's precision errors. Probably. Because it's probably precision error. Because it's 0, 1, 2, 3. And maybe because 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Probably rounding errors. Dude, why are these? Why do these have? Oh. These ones. These ones. Okay, let's leave it at that. Let's move them at this is 1, so it should be like this. Yeah, like that. Like that. And we can make more rows like this. We can make more rows like this. This should be, Yeah, but this is yeah, okay. We can execute I want control of the I variable. Execute block of code times many times with I starting from I. Start value. And here we will set it as I start value, and here it will be I start value plus times. So here, how many times with I execute block of code? It should be 16 times with I starting value 0. And we copy this code. And this time starting from 16, and here we should bring this down. Should bring this down by how much? I'm not liking how it is right now. Minus 25. And we render execute block of code 32 times starting from 0. Let's see what we got. We should have gotten another one. We should have gotten another one. Yeah, I'm lowering it. Oh, okay, we can do an F here. Still the same. What's the issue? Like if we do this 8 and we remove this, is that the issue? It's still the same. What? Maybe it's not rendering. Execute block of code 32 times with I starting from 0. Call render variable. Yeah, it should be working. What's the issue? Here we set it to like this. 16, set position, set color, and we render them. Shader program, we render them. So what's the issue? We have enough blocks. We set the position. The position is all right. It's lower. but nothing is happening. Nothing is happening. We'll probably have to end the stream here. Like, we're closing on 5 hours. The stream got too long. But one last try, man. One last try. Why is it not rendering? Execute block of code 16 times. Oh, it is working. It is just sending them too far off right. So here, I see. So here must be minus 16. Now it should work. What? Oh, it's here. It's here. Okay, so the positions are at fault here. So it's it's a mistake. Oh, it's yeah, it's a mistake. It's a mistake. It's a mistake. Yeah, of how my program works. Yeah, it's a mistake on my part. And here it is. Yeah. Let's finish this level. No matter how ugly the code is, let's finish it. We need to do 4 of these. Sadly, sadly we have to do 4 of these. Oh my god, what a mess. So this should start from 32. 16 times this from 32, and here from 48. And the colors should be 58, 58, 58, and 29. And this should be like this, but times 2, and this times 3. And here, man, this is so ugly code. This should be copied minus paste. This should be 32. This should be 48, and we should render 64 of them, I think. Let's check it out. And here it is. Man, this is so... 4 more rows. Why is it so laggy in VS Code? Okay. You know what? The code we have here, we can copy it. We can paste it here, and we can simplify it. Create blocks from I to from A to B, from A to B. This is A to this is B, where we set the position as this is A, for level, and we with color red color color, and here we just will replace this. So this should be create blocks from uh, 32 to 16, so 48 on level I think 3 with color yeah, inside this. Okay, and we want once more for, no, this is level 2, same color, and this is from 48 till 64, and we should delete this, and we should get the same result. Okay, same result. It's just a bit better now. What made you wanna do this plain English coding thing, and do you find it to be easier or more readable? It's a bit annoying to code like this, but it's really helpful for when I want to focus on what I'm learning, not the syntax. So here is the code that gets generated, or like this. This is the code that gets generated. Right now I'm focusing on what I'm learning, not the C++ syntax. And when I get comfortable with OpenGL, I will move to the syntax, and it will be just the syntax of C++. Right now I'm abstracting away. Okay, now we have to write the other blocks. Create blocks. Now these are from the 0th to 16, and these are from 16 to 32, I think. And this is level 1, this is level 0, and the colors, where are the colors? Set color here, yank inside this. And we need to change these colors. Yank inside here, paste, and delete here. And when we delete this, and now it should be the same as before. Here is the same as before. So now it will be a lot easier to create the other parts. So other parts. The other parts. The other is from 64 till 70, 80, I think. And this is from 80 to 96. Did you make the thing that translates the plain English based on the rules on the right? Are you using No, I made it. I made it myself. I made a compiler for that. I made a compiler that has a lexer, parser, and evaluation, and it evaluates it. So it reads through all of this. It assigns hello. I'm really happy that there are this many people on the stream and this many people interested in my project. This coding in English, you can find it. Thank you for following. Tomb.com. Is it open source? Right now, I haven't open sourced it, but I will for sure open source it. I really value my way of writing projects is to make them open source. Videos here. Where is it? Code in English. Here, code in English, and it's my most popular video with almost 90,000 views. And here I go more in depth. And here I show how programming languages have different syntax, but the meaning is quite the same. And so why not just use the comments and dynamically change them? And here, my first game, I made it with Phaser. And right now, I am making it with OpenGL from scratch. Okay, 64, 96. This should be on the 4th level, and this should be on the 5th. And the color, this is 1st, 2nd, 3rd. So 0, 1st, 2nd. no, 0, first, second, third. So test block 3, so this color, so this should be 0, this should be 52, and this should be 0. Yank inside here, paste, delete here, and let's check it out. Oh, we have to render it. No, we have to render it. Is able to make it easier to learn syntax. I agree with one of the comments on the video. The syntax is not the... Yeah, syntax is not the hard part. I'm just putting it off for later because it's not hard, but OpenGL to learn on itself is hard, and adding syntax on top of it makes it unnecessarily more harder. With this, I am temporarily just focusing on OpenGL. And when I get comfortable with OpenGL, I can easily move to the code because it compiles to C++. We can right now go in here and just start writing in C++. Think of it like training wheels for riding a bike. Like you can at any moment remove the training wheels. I hate to be that guy saying AI, but won't it get easier to learn OpenGL with AI? Absolutely. AI will revolutionize everything in life. But right now I'm looking at the where are we right now. So, but even if AI makes it easier to learn OpenGL, like why cannot AI use my language, programming in English, so that when people start programming using AI that cannot code, they can use just this and not have to use any syntax. Okay, let's test it out. And here we have these ones. So we have few more, one more level, I think. So we have... I've never done any OpenGL stuff. What do you think is a good benchmark for this person knows OpenGL reasonably well? Well, I started learning OpenGL. Obsidian, let me open this. Like I documented my process and I am on my... Like here I started learning just rendering triangles and I'm on my... which one? I'm on day 10. I'm on day 10 and the reason I've progressed so much is because, in my eyes, because I'm coding with English, because I'm focusing just on OpenGL. But for your question, like, I'm not sure if it's I'm the right person to say it, because like I showed you, I've been learning it for 10 days. Thank you for the following. My program here cannot read the follower's name, right? So I have to fix my program. This slider below, I've made it also. I made it yesterday for the entire day. It took me quite a bit. It takes comments from YouTube as well. Test. It should show from YouTube. And here it is. Here's from YouTube. From my YouTube stream as well. I haven't seen a streamer with a horizontal chat. And that also takes in from both streams. Okay, this is what I'm trying to do. Like, I'm using this guide. This is the best OpenGL guide, and they have a guide on creating the breakout game. I am not reading their guide for making the game. I want to first try to do it with the basics I've learned from the getting started section. I'm attempting to use what I know and to see how far I can go. And when I reach my limit, I'll check out the full tutorial on what they have to say, because they're creating a game class, they're doing it properly, and I'm doing it a lot worse. But I'm doing it on purpose this way because I learn the fastest doing it this way. So right now we have the orange ones, these ones, the greens one. Okay, we have to add the blue ones as well. We need the blue ones as well. So the blue ones, let's get back here and let's render. So they're from 96 till 112, I think. 112 till 128. And this should be on the 6th level, and this should be on the 7th level, and the color should be the blue color. So 14, 43, and 72. Yank inside here, paste and delete, and so here we render all of them. 128, and now let's render. Let's start it, and here we have it. And let's delete these ones. These were just temporarily. Let's stop rendering them and let's delete them. And let's run it again. And here it is. We got our first level. Oh man, this was so much work. This took me how much time? 5 hours. This took me 5 hours. Oh my god. This took me 5 hours. I set a limit of 4 hours. So probably I will not continue more, but tomorrow probably. Probably tomorrow we will add the paddle, this thing, and add a ball, and add collisions. Yeah, that's what we will do tomorrow. But it's enough for today. The stream is getting too long. Stream is getting too long, so yeah, that's about it. You can see me tomorrow. You can check out my schedule. You can check my schedule, channel, schedule, and here I am every day from 6 a.m. to 10 a.m. and that's it. So thank you for watching. We've done enough today, enough work. Okay, goodbye and thank you for coming in.